Welcome to this tutorial. In this tutorial we're gonna do exercise 1 that you see right now. A program takes we're gonna write a program that takes as argument two values n and p and starts n threads, and each thread receives the values n and p as well as the number of the thread, including beginning from 1 till n of the thread, and computes this formula. And the main thread prints the sum of computed UT values. So here we're gonna create a structure. First, let me explain the exercise. Here we're gonna calculate this formula, and each time we'll get the value of UT, and for each thread it's gonna be it's gonna change, and then in the main thread, in the main function, we will print the sum of the computed UT values. Okay, so each thread is gonna have some values. I don't know. Let's say that we have 3 threads, so we have 3 different values, and in the main thread we're gonna print the sum of these computed UT values. Okay, and which is the value computed by the program. Write it. This is the end value, last value that the main thread is gonna print, which is the sum. Okay, now let's begin. So here, firstly, we should include the headers that we're gonna use, and I have written them in the headers h file, and this includes standard input output, library function, stdlib, pthread, and unistd. Actually, I'm not sure that if I'm using all of these libraries, but this at least these 2 it will be used, and this 3 will be used. Yeah. Okay, now we can begin. So firstly, I'm declaring here the structure, because when I create a thread with the pthread create function, I'm gonna pass, as you see, I should pass different values, which are the n, p, and t, and as a result I should get the value ut. So I have multiple values, so if we have multiple values as argument, we're gonna use a structure instead of just a variable. Okay, that's why I'm declaring a struct. So this structure will be used for thread input and output as well. Okay, structure for thread input and output. So this struct, I'm gonna call it just arg, and this struct contains the members n, and then p, which is the from I till p, and which the user is gonna give this value, and then there is t as well, and at the end the return result, which is the ut, so I can call it long u, and this will be return or result or sum, I don't know, I just call it result. Okay, so as I declare this struct, so now I want to write a function or start routine function where the thread, when we create the main thread, the main thread is going to begin the execution in this function. So its type is pointer to void, or void pointer actually, and we are using void pointer because it's out of content, but still let me say, when you are using void pointer, it means that you are the address that you point to, in that address any value can be stored. It's like it's typeless. yes, it's typeless address. So I don't know if I have explained it somewhere in the previous videos or not, but anyways, so this is going to take a argument which is a void pointer, and in this I have called this function as calculate, and this is the start routine function. Start routine function that you can see that the pthread crate, in the pthread crate it is called like start routine function. So here I'm using the struct that we have, and I am creating a pointer. I'm using pointer to struct, and actually what I want to here is I just want to write it like that, so that it means that here arg, the argument that we pass to the function, will be assigned to the address pointed to by a. Okay, so yeah, it's pointed to by a, and then I can access the members of the struct, which is firstly I'm gonna initialize the u to 0, and then as we see in this formula, we see that beginning from I, which is 1 till p, we're gonna calculate the sum of this formula. So the for should be like int I beginning from 1, I is less than or equal to p, and I plus plus. I want to get the sum of sum of the formula, which is the t minus 1, which is a t t minus 1 multiplied by a p and plus I. And yes, so I should put them in the brackets, and here yeah, when we are using a pointer, we should use a row to access the members. And thus we get the value of ut, and if we want to print out, I am just gonna write it as this u as it is shown in the formula. So I'm just gonna write it u percentage d is equal to percentage d, and it is actually first is at, so the second argument is the u, which is a arrow u. Okay, and thus we can see the output as we want. And then in this thread I'm using pthread exit function, so and I am passing argument. So what it means, it means that when you're using pthread exit, this function terminates the calling thread or the calculate thread here. So if you are using exit, it will terminate the whole process. But if you want to terminate only one thread, you should use pthread exit function. So here why we have passed the arg, because arg, let me write it here, arg will then be passed or will be copied to the location that pthread let me just here, okay, let me write it here, pthread join retrieval points to. Okay, so you will see why we need this, because in the pthread okay, I'm gonna explain it later, but firstly I want you to know that why we use what arg is gonna be used as. So arg will be copied to the location that pthread join retrieval value, return value points to. Okay, then yeah, this is all about the start routine function, and yeah, we can begin the main writing the main thread. So here I want the user to input it from the command line, so that's why I'm using argc and argv. And then I'm again declaring n p, so the user will enter, and for sum I'm using long sum, where I will calculate the sum of all of the threads values. All right. And I'm using again struct argument here. I'm using the pointer a, and firstly I should check if argc. I can check actually if argc is equal to 3. It means that n and p, I want n and p should be n and p to be entered from the command line, so it's gonna have 3 arguments. Okay, and the first argument will be the name of the executable file, and the rest will be used for n and p. So here, if argc is equal to 3, so we can print it like to std that usage of this executable file is like n and p, and then the first argument, which is argv0, which is the name of the executable file, and I do exit from here with exit failure. Okay, and then I continue. So the user enters n and p, and a to i I want argv1 to integer n, and to represent n, and I want argv2 or third argument to represent p. So that's why I'm writing it like that. Okay, and then yeah, and then now I have n and p. So what I can create here is pthread t, the table of thread IDs. Okay, because I'm not having here one thread, but I'm having a n number of threads. So that's why I'm creating a table for a thread ID, and it has the length n. All right. Then now our main thread starts from here. So I'm using int again for I is less than n, I plus plus. So here the n number of threads will be executed from now on. So firstly, I allocate memory for the a struct a, and its size will be memory of a. And when we are using malloc, it allocates a memory block, and it returns a pointer to the beginning of the block, and then we can again access the members of the struct. First member is n, and in the struct the members are stored sequentially. Okay, so that's why firstly I Yeah, I just want you to say that. So n will be assigned to the struct member n, then p will be assigned to the struct member p, and for t, as you see, the t includes begins from 1 till n, which is the number of the threads. So I am writing it as I plus 1, which begins from 1 till n, and then yeah, these are all the values that I passed to the struct or to the function, calculate function, and now I can create a thread. Yeah, I can create a thread. So to create thread, we are using pthreadJoin function, which as a first argument takes the address of the thread ID, which if it is the first thread, it's going to be tab T0, if second 1, etc. As a second argument, it's taking I'm sorry, I'm using here join. It's not join, but it's create. So when we are using create, so you see, I just want to say, yeah, the second argument is the attributes. So if we want the default attributes, we just can pass null here. The third attribute is the third argument is the start routine, which is a function. So here we pass the address of the function that we want the thread to begin execution, and the last argument will be the argument which is the struct arg here. So we pass it as a. So as I said to you, if we pass more than one arguments, we are using a struct here. So pthread function returns 0 in a successful creation. If it's not equal to 0, we can check it. Just write pthread create, and then we can exit with exit 1. And now we so in this for loop we create thread and we do execution for each of them, and then what we want to is in this phase I'm gonna write waiting for termination. Now you will see that why we use argument here, why we needed this second. So far the main thread will calculate the UT values for each thread, but what I want to is to print the sum of them. So because of that, I'm writing sum. First I'm initializing sum to 0, and then I'm using for loop again to calculate the sum is less than ni++. So here I'm using again a struct argument, and I'm using here a pthreadJoin. Why we use pthreadJoin? Because when you use pthreadJoin, the thread that you specify in the first argument, which is gonna be tab ti. So the main thread, the calling thread, will wait for this thread's termination. All right. And as a second argument, I am passing the if we don't want to get the the exit status, or if we are not going to use it, we can pass no. But here I want to access to the structure that is calculated in this calculate function. So I want to access it, and I want to access it, and I want to use its AU value in order to find sum. That's why I'm passing it as the second argument, but it should be void pointer to pointer, and the others of the struct, which is A. So what will be here? So here the arc, whatever the arc gets, so it will calculate the AU, and this arc will contain n, the value of n, p, t, u. So if we want to access n of them, in order to access n of them, we are passing it to pthread exit as argument, and then this arc will be copied to the location that this value points to. So it's like the argument will be this struct, the members of this struct, their values will be copied to the to this address we show it here. Okay, that's why it's important to use pthread exit, and pthread exit in the thread that we want to use. If we want to use the thread's exit status, we should use pthread exit, and if we want to use it in the another thread, we can use it with pthread join. And yes, pthread join, and if it is equal to -1, then there is some error with pthread join. So I'm just gonna write pair p join and exit 1. And otherwise, I will just add the value of each thread's the value that after each thread calculation, the value that I get will be added to the sum. Thus, I can get the result value. And yeah, and then yeah, I can use free A in order to deallocate the memory that is allocated for this struct. After that, I should print the sum, which is equal to %d, which is sum. Okay, and return 0. Now, when you compile this, when you compile the script that you have using Posix thread, you should link pthread here as well, and then yes, oh okay, so here the data type is long, and I should pass LD, and for the sum here it's also long, so I should change it to LD. And let me, okay, and then so if you pass just a.out, which is the executable name, so it prints you the usage should be n and p. So let's say I want n3 and I want p5, and it calculates. So as you see, we cannot say that which thread will finish first, and second thread has finished first, and then 1 and 3, and then we got the sum of all of them. And if we compile it again, so we see that they have changed their place, etc. So I hope everything is clear, and if you have any question, feel free to ask.